So for this problem, we want to know how fast we'll have to push on this block so that 5 seconds later it's moving at this speed. So our first step is going to be in figuring out what our net force is for the system. So we start with our initial velocity, which is when it's not moving, which means our initial momentum is 0. Then we find our final velocity, our final momentum, and then use this to determine what our net force is going to be. So now we need to account for all the different forces acting on our system. So we have friction pointing in the opposite direction of the pushing of the box, and then the normal force normal to the force of gravity. So because the box isn't moving up or down, the net force in terms of y is going to be equal to 0, so that means that the normal force is going to be equal to the force of gravity. So then we solve for the force of gravity, and then we know that this is going to equal our normal force, and then we use this to find our frictional force by multiplying by our given coefficient for the surface and the object in question, and we use this to find the frictional force, which is given here. So now what we want to do is determine what our pushing force is going to need to equal so that we have this given velocity at 5 seconds. So we plug that into our equation, and we know that the net force in terms of x is equal to the force of friction and the force of our push added up together. And so we know from our original, this work right here, that our net force is going to be equal to this. We already know that our net force in terms of y is equal to 0. So then we can write the net force in terms of x is equal to 20 newtons, which is equal to our frictional force plus the force of our push. So then it's just a simple algebraic equation to solve for our one variable, which is how hard we need to push, and that is given here in terms of just the x direction or as a vector. And so that is how strong the force will have to be so that this block in 5 seconds will be moving 5 meters per second.